Hi everyone. More problem in AB calculus review. So this one it's about finding the position of a particle. So basically we're gonna go over uh, the the distance, the velocity, and the acceleration. Okay, let's read the problem here. So it said a particle move along a straight line so that at time t greater than or equal 0, its acceleration is given by a t. So the acceleration a t is equal 12t. Okay, good. At t equals 0, what happened at t equals 0? Okay, the velocity of the particle is 2. So v of t, which is v of 0, equal 2. This is when, okay, and the distance, the particle is 2, and the position of the particle is 5. So position, its mean distance. So d at t, d at 0 equal 5. So he wants to know the distance, found the position when t is greater than or equal to 0. All right. Okay. So let's get right to it. All right. So first thing we know, the acceleration is the derivative of the velocity, dv dt. And the velocity, it's a derivative of the distance, which is a change of the distance over time. So we can write equal to d over dt. We can substitute for the v, which is dx over dt. Right? So that will equal, so this is 2 derivative, which is equal to 2d, the derivative is 2 times, so d square x over dt square. All right? Okay. So the derivative of the distance is the velocity, and the derivative of the velocity is the acceleration. And integration is a reverse of this. So the integration of the acceleration is the velocity, and the integration of the velocity is the distance. Okay, so let's stick with this one. So we say acceleration equal dv over dt. So we can say dv is equal a dt, right? So let's get the integration. So we take the integration for both sides. So integration of dv equal to integration of a dt. What's the integration of dv? Is v. And then what's the integration of integration of dv is v. And then what's the integration of a? We already know what's a. We have the a here. It's 12t. So we can say 12t dt, which is equal integration of 12t, increase exponent by 1, and divide by the new exponent. So will be 12t squared over 2 plus constant c, right? So we know already we have given, we can use this given in the equation. So at t equals 0, the velocity is equal to 2. So the equation here, the final equation will be v equal 12t squared over 2 plus c. So we know at t equals 0, v equal 2. So let's substitute. So v equal 2, so we'll be here 2 equal 12 0 squared over 2 plus c. So that will lead us to c is equal to 2. Okay. All right. So let's write down the equation. So substitute for the c, velocity. So velocity equal 12 t squared over 2. We can simplify this, so it would be 6 t squared plus c is 2. Okay, so this is my first equation here. All right, so let's make it 1. Okay, great. Then we wanna, so we got the velocity. We wanna get to the distance from this equation, and we said the distance, basically the integration of the velocity is the distance. So from here we say v is equal dx over dt. The change in distance over the time, that's the velocity. The same exact concept we're going to apply. So will be v dt is equal to dx. So take the integration for both sides. So it will be v dt equal integration of dx. So integration of dx, it's x, equal integration of v dt. We know already the v, it's equation right here. So we're going to substitute. So the integration of 6t squared plus 2 dt. Okay, let's integrate this. So it will be equal 6t squared. So we'll increase the exponent by 1 divided by the new exponent. So it will be 6t cubed over 3 plus 2t plus c. Let's call this c dash. All right. Same exact. So we said at t equals 0, we said x equal 5. Right? It's from here. Okay, let's substitute here. So we have the equation here. X equal 6t cubed over 3 plus 2t equals c dash. So at x equal 5, at t equals 0. So this will be 0 plus 0. This is plus c dash. So that means c dash equal 5. So that's my second constant. So let's put everything back to the equation. So it will be x equal 6x cubed t cubed over 3 plus 2t plus 5. Okay, let's simplify this. So it will be x equals 6 over 3. That's 2t cubed plus 2t plus 5. And that's going to be my equation. Second equation. And that's the equation of the position of the particle. So that's basically the position of the particle when t greater than or equal to 0. That's it. There you have it. That's the answer for